So another sustainable feature, talking about that living lab idea before, where we're using the campus to do research. It's essentially the entire building was installed with circadian rhythm lighting. The lighting matches the spectrum of light from sunrise to sunset, which and essentially we're studying the impact on that because we think that there's quite a lot of benefit to that. Um, Another interesting thing is the facade. Um, it has a unique um, uh, enclosure essentially. It's made of a hydroformed tensile steel. It's structural steel, and essentially it was created by a team of engineers and lighting and climate specialists, and they basically created a material, a stainless steel material that allows the building to maximize the solar gain during winter months and reduce it during warmer months. And the idea is that it actually helps shave the peak loads on the building, and it works very well. Every one of the pieces of the facade has its own special shape and design depending on where the sun's coming. There's actually 14 different shapes of the steel, and it essentially, like I said, it really helps keep the building cool, but also insulate the building or allow that daylight harvesting in the wintertime. And this is actually mostly installed in the laboratory buildings, or in the laboratory floors, which are higher up in the building. And you can see it right here at the end of the hallway. This is what it looks like looking out. The building was, like I said, it was installed with the 2050 goal in mind, becoming fossil fuel free. However, we're not quite there yet, so we had to install a natural gas, a very efficient natural gas district energy facility, which is located about a block away. Essentially, it's a produces chilled water and hot water. It has a 1.3 million gallon tank to produce chilled water storage during off-peak times, and this is when energy is cheaper and less polluting, and it also sort of acts like a battery for the building. And it's also partly cogeneration as well. And like I said, this was designed with 2050 in mind. We also looked at the building from a resiliency standpoint for year 2100, sea level rise, storm surge, and that sort of thing. So part of the reason the piping is higher up off the ground, and there's a lot of other pieces like that. It's meant to brace those worst case scenarios of storm surge, since we are near the ocean here in Boston. And this will essentially allow the SEC building to operate as a community safety place in the event of a major storm. And this facility will also power some of the other buildings that's going to be built in the neighborhood. And then I wanted to mention this too. This is rainwater storage. So the building, the area has a lot of green space around it, it's all collected into these main tanks here. And this is 75,000 gallons of rainwater is what this holds, and it's actually used for the reverse osmosis deionization water. It's actually produced from the water that we're harvesting on site. So this is a photo that I took from the rooftop. We've since installed solar panels. They were not installed pre-occupancy, but we got them in there right after. We also have a major energy recovery system, Convecta. At the time it was designed, it was the largest in the world, and around 2018, 2019 when it was going in. I think it's been surpassed by now, but essentially this is our major energy recovery system, and also with the reduced air change rates as well. This is just another way to reduce the overall energy used by the building. This is a photo of the internal area. There's a lot of these spaces that are meant to be shared hoteling spaces, so people who travel here to work here for the day or a half a day have lockers where they can store things and rent small rooms to do their work. And there's plenty of places like that. It basically allows for a nice community sort of space that makes it more inviting, because this is supposed to be a building that's really inviting people from the other side of the river to our new campus. And you can see here, like for the rainwater savings, we have all these green roofs. This is an aerial view looking down. There's a parking garage and loading dock underneath. And this is meant to be like a major like event space. You could have concerts, commencement, and all the landscaping is local species and things like that. I could talk about it a lot more, but I think I've already went over time, so I think I'll go ahead and end it there.
So thanks a lot, Quentin. A lot of details, a lot of cool pictures. I love the landscape shapes and also the facade shapes and the possibility to bring light in winter and block lightning in summer, and such really clever things. Really amazing. We have a question in the chat for you. What selection criteria was applied while selecting material of casework and fume hoods?
So the selection criteria for casework and fume hoods. Actually, let me see if I have more details on that. The one thing I can essentially say is that the big focus around the materials for my office was on the chemical reduction, the removal of toxic chemicals. Well, that being said, there are, for safety reasons, potentially reasons why, not every single one of those chemicals was removed. Most of the time that they were, we have found a lot of workarounds, and found natural chemicals in that work. But yeah, I don't have any other details beyond that around the casework specifically. I know I got to essentially participate in a selection mock-up for design, but I don't have any details on that.